Hello and welcome to Chapter 2, where today we're going to be focusing on factors and multiples. Last week we had worked on number systems. If you haven't watched that video, go to the channel and go find it. It was posted 1 week ago. And yeah, so we saw a lot of positive response on that last video, so I think you guys find it interesting to do more. So let's do Chapter 2 now. And again, this is for grades 7, 8, 9, and 10. So let's start with the video. So they're asking us what is a prime number. So this can be a question that you get sometimes. And well, the easiest definition of a prime number is a prime number. I'll just write it. A prime number has two factors. So you can just write two like this, factors. What this means is a prime number can only have two factors, which is 1 and itself. 1 and itself. So for example, what's a prime number? Let's write some prime numbers. So 2 is a prime number because the only factors of 2 is 1 and 2. 3 is a prime number because 1 and 3. 4 is not a prime number because 2 is also a factor. So 4 is not. 5 is, and so on. So numbers that have 1 in themselves as a factor are the numbers that are prime. So very simple. Let's go to the next question. Very simple question this was. Just describe it like this. Okay, so now as we're working on factors and multiples, we're going to be discussing something called HCF, which stands for highest common factor. And then also next page is going to be, I think next page or some pages after, we're going to be working on LCM2, which is basically lowest common multiple. So today we're working on factors and multiples. Well, highest common factor and lowest common multiple. So that's why it's called the chapter. But yeah, right now we're actually supposed to be doing the HCF, or highest common factor, of 72 and 120. But how would we do this? So I would write these two numbers separately. So 72 here, 120 here. Now, what I'd do here is I'd slowly but steadily break down this number. So I'd have to divide it again and again and get lots of factors here that divide into 72. And I'll show you what I mean. So we can see 72 is divisible by, for example, 2. But how much? It's 2 times 36 is 72. And what about 36? What can we divide 36 by? Yeah, I think we can do it by 2 again. Now this is 18. And what else? Can we do 2 again? I'm pretty sure we can. Yes, 9. Now we can't do 2 here. Well, we can, but that would give us a decimal point, which we wanna avoid if possible. So I would do 3, because 3 is the next number after 2, and 9 divided by 3 is equal to 3. And then to take this off, we just do another 3, and then we have 1 here. So I'm just going to erase this 120 right now, so I have more space to explain. So we can say 72 equals to 2 times 2. So all of these numbers on this side, we can say 72 equals to them. So we can say 72 equals to 2 times 2, then one more 2 times 3, and then one more 3 times 3. And let's check if this is correct. So 3 times 3 is 9. So basically, rephrasing this, it would be 72 equals to 2 times 2 times 2 times 9. 72 equals to 4, because we know this is 4. 4 times 2 times 9. And we know 4 times 2 is 8. So 8 times 9 is 72. So I am now going to erase all this. And I'm going to write, wait for it. Just get this all out of the way. Yes. All right. So I'm going to write up here 72, and I'm going to write the numbers 2, 2, 2, 3, 3. Now we have to do the same thing for this number, next number, which is what, 120? So we write 120 here. We divide it by, we can see it's already straight divisible by 2 as it's an even number. We can have 60 here, 2 again, 30, and then 2 again, and then that's 15. Now 15 divided by 2 would be 7.5. However, I don't want to go in decimal points like I said last time. So what's the next number that comes after 2? Does 3 work? Yes, 3 works. It makes it 5. And 5. 5 works as well. 5. 2 doesn't work for 5. 3 doesn't work for 5. 5 works for 5. And then we just put a 1 here. So we can say 120 equals to 2, 2, 2, 3, 5, right? Now, we've got these sets, but how does that make us find the highest common factor? How do we find this? Well, it's very simple. We take all the outlying numbers, so all the numbers that come in 72 and in 120. So I'll show you what I mean. I mean, we can find a set of 2 here, 2 and 2. You can see they're both common in 72 and 120. So we take 1, 2 here. And you can see there's one more 2 that's common in both of these. So we can have another 2 here. And then 2, another 2 that's common, because we're finding the highest common factor. So we need to find all the common numbers in between of both of these. So we find another 2. So there's 3 2's common. Then there's another 3 common. And 3 and 5, well, they're not common, so we can't have any of them. So what are our 4? We have 4 common numbers, which are 2, 2, 2, which are 2, 2, 2, and 3. Now, what do we do with them? We just multiply them. So 2 times 2 times 2 times 3 is 4, because this is 4, and times 6, this is 6, equals to 24. So that means our HCF equals to 24. Simple. So that means, yeah, very easy. Yeah. Let's go to the next question, which is LCM now. As I explained, LCM is lowest common multiple. And how do we do that? Well, we'd write all of these 3 numbers, these 3, and we'd put them like this. I'll show you. 21, 45, 63. And by the way, these 2 methods that I've shown you right now, the first method I'd shown you for HCF, that was one method to do it. In my opinion, that was the easiest method. So it would be good if you use that method, but it's your choice. But this is another method for LCM. This is a method for LCM. You can't use this for HCF. Now I'll show you what I mean. So you have 3 numbers here. Now we have to find something. We have to divide this by something that works in all. So we can see 3 works, right? Because 3 divided by 21 is 7. 3 divided by 45 is what? 3, 1, 15. 15, right? I'll just erase this and make it more neat. 45, 3. So this is what? 15. And I know 63 divided by 3 is equal to 21. Well, so now we have 3. Now, next, I want to get rid of this 7. So I can straight up divide it by 7. It won't make a big difference to 15, but it will make a difference here. So we can say this is 1. Our final goal, before I actually continue with this equation, is our final goal for all these numbers, 21, 45, and 63, is to have them as 1, 1, 1. So that they're all 1. Right now they're full numbers, but we've got 1, 1 already. We've completely done this. We've found this. And 7 divided by 15, well, it's in points, so I'm not going to do that. I'm going to keep 15 here. And 7 divided by 21, well, simple, 3. Now we can divide this by 3 again. What does this do? It makes us get 1 here. Stays the same. But 15 divided by 3, well, very simple. 15 divided by 3 is 5. And 3 divided by 3 is 1. So perfect. We've got 2 1s. Now we have to make this one, this number 5, a 1. How do we do that? Well, let's divide this by 5. And then we get 1 by 1 by 1, which is the final outcome. Now, these numbers over here, you might be asking, what do we do with them? Well, again, you just multiply them. So what you do is 3 times 7 times 3 times 5. 3 times 7, 21. 3 times 5, 15. That's 21 times 15. Let's do it here on the side. 21 times 15. 5 goes here. 5, 10. Oh, I messed up a bit. Let's do this again. 5 ones are 5. 5 twos are 10. Perfect. 1, 1. And let's put this here. 1 times 1 is 1. 1 times 2 is 2. 5, 1, 3. 315, I think, is the answer. Yes. So the LCM, lowest common multiple, of 21, 45, and 63 is 315, which is the answer. Now let's go to question number 3. Oopsies. It says question number 4 here. Ignore that. It's question number 3. I'll just ignore this. It's question number 3. Now it's asking us for HCF of 3 numbers this time. First we solved the 2-numbered one, but now we're doing a 3-numbered. It's not that hard. Let's just write 15 first. Let's solve for 15. So what we do? Well, we divide this by 2. Doesn't work. 3 works. So we put this here. 15 divided by 3 is 5. 5 divided by what is 1? Because we want 1 here, ultimately. So 5 divided by 5. So this is for 15. So let's just write this here. 15 is 3 times 5. Exactly. Now we go 45. All right, 45. What do we do with 45? Well, let's start. 2. Does 2 work? Well, no. We know it doesn't because it's equal to 22.5, but we don't want negatives. I mean, we don't want decimals. So we're going to do it by 3. By 3 it works, I'm pretty sure. Yes, it does. 15. Next, what does it work by with 15? Well, it works by 3 again, and this makes this 5 and 5. So now we can write 45 as 3 times 3 times 5. And now the last one is 60. 60, and well, I'll write the 60 again. A bit better. Yeah, that's much better. 60, oops, sorry. 60. Well, what's the smallest number we can put into this? Well, 2, because it's an even number. We make this 30. Again, 2 works. 15. Well, we know 3 goes. 5 comes here. 5, 1. Now we have 60 is 2 times 2 times 3 times 5, right? And so now we can find what numbers are common. So we can see 3 is common here. 3 is also here. Well, 3 is also here. So 3 is a very common number. We can say 3 is common in all of these 3 numbers. And what else? In 15, there's 5. Well, is 5 common here? Yes, it is. Is 5 common here? 5 is also common. 3, 5. Now there's an extra 3 here, but there's no 3 here, and there's no 3 here. So this 3 gets cancelled. Again, 2's, we cannot see any 2's anywhere else. So these 2 are also cancelled. So we only have 3, 5. Both are numbers. Well, what's 3 times 5? Very easy. 15. So our highest common factor, or HCF, I'm just going to write highest common factor, or HCF is 15, right? Very easy. Let's go to question number, if this was 3, this was 4. All right, I'm actually going to write that a bit better. 4. Yeah. Find the LCM of 6, 32, and 112. So LCM, we have to write all the numbers together. I'm going to write a bit more top so that we can get a bit more space. 6, 32, 112. Now, let's do this dividing. Well, I can already see all these numbers have one common thing for now, which I can see is it's divisible by 2, which means it's even. So we can write 2 here. We get 3 here. 2 divided by 32 is 16. 2 divided by 112 is, let's see, 5 and 56. And then here now, let's try 3 because we want to get this to 1. So this is definitely a 1. 3 divided by 16, we cannot do it, so 16 stays. 3 divided by 56, well, 3 times 1, 26. No, we cannot also do this, so this stays as well. So we've got 1, 1. Now 16 and 56, what's common? They're both even. Divided by 2. 1, 8, and 28. Again, common. Divide by 2. 1, 4, 14. Let's continue this here. We've got 1, 4. Let's just forget the 1. Let's have 4 and 14. Right? Because 1 is done already. Divide this by 2 again because they're even. 2 and 7. Then quickly by 2 to make this a 1. Sorry, wait. And then this is 7. And then 7 to make both of these 1. So in total, our numbers are 2 here. 3, 2, 2, 2, and I think that's another 2 actually, and 7. Let's erase all this so we can make more space to do our final calculation, which is looking for multiplying all these and then finding what our LCM is, which should not be that hard. Yeah, so 2 times 3, as we can see here, is 6. 2 times 2 is 4. 2 times 2 again is 4. And let's just keep 7 how it is. 6 times 4 is 24. 4 times 7 is 28. Let's do 24 times 28 in this corner right here. Well, 24 times 28. 4 times 8 is 2, and 33 goes up there. 16, 19 times 2, 8. 2, 4, 4. This is non-applicable anymore. 4, 4, 4. 2, 17, 672. I think that's the answer. 672. So our LCM, lowest common multiple, is equal to 672. And now the homework questions. So try doing the HCF of 225 and 135, the HCF of 65, 78, and 104, the LCM of 54, 72, and 12, and the LCM of 34 and 67, and write them in the comments, and let's see how they go for you guys. Thanks for watching. Like, share, and subscribe, and we'll see you next week.